Guys, so I'm back with a new video. So as told in my previous video, that in this video I'm going to discuss about the differences between your binomial and your Poisson's distribution. Okay, so how will you identify in your examination whether a particular problem need to be solved using your binomial or Poisson's distribution? Simple. Okay, how what are the parameters, what are the criteria? So in in case of binomial distribution, you will be given your p value, your q value, okay, and your n value. Okay, so always remember that in binomial distribution your p value will not exceed below below zero point 0.1 value. Okay, that means I mean to say is, so only one decimal point will be given in your binomial distribution. Okay, that means your zero point 0.1, 0.2, 0.3, or else 0.95, 0.28, 0.32, like this. I mean to say, general thing I want to say, that after your point, this zero will be there. After your point, there will be some number. There will be some number. There will not be a zero or something. Okay. Okay, this is the first parameter. First parameter, you have to see that both PQ values should have, that, like 0.1. After point there should be a number, a valid number, that is a non-zero number it should have after the point. Then it is to be done using binomial distribution. If such conditions appears, then straight away you can do it binomial distribution. Second condition, you have to still, you can, if you are not satisfied with this, you can check your n value. In binomial distribution, always they give some reasonable, some very low value of n, that is your 10, might be your 5, or else they will be giving n value 3, or else 20, 30, 50. Only approximately you can round it off up to say 80 or up to 100, not also 100, only up to 90. Up to 90 you can mark it up to 90 they might give your n value. That means I want to say that n value will be very low in your binomial distribution. If you find any question with a low n value and with p and q value is having the numbers after a non-zero number after your point, after your decimal point, then that problem is need to be solved using your binomial distribution. I hope it is clear. Okay, now what the case will be in your Poisson's distribution? Poisson's distribution. So as we know that and q will not be the values. They'll not give p and q, but just they'll give some probability. Okay, if my probability in Poisson's distribution, how will they will give? After point, there must and should be a zero. After zero, there it can be like some 2 or 0 0.03, 0 0.04, 0 0.05, 0 0.06, like that. Okay, na? Okay, that means the basic thing which I can say you in binomial distribution, p and q value is bit more, but less than 1 only, but it is like 0 0.1, 0 0.2, 0 0.3, it is little more. But in your Poisson's distribution, your p value will be very low, even lesser than your 0.1 also. It is very low in this Poisson's distribution. So by seeing this, you can clearly identify your problem, that this is so and so method. Okay, so now this is the method. Okay, 0 0.02, 0 0.03. Okay, if you got this number, then you can do it Poisson's. And also here second parameter is n value. That means here n value will be very high, around 100, 200, 1000, 10,000, 7,000, 5,000, or like this. The n values will be very greater, like 100. In terms of in most of the problems, they'll ask in terms of hundreds only. N value will be most of the times in hundreds only. Okay, so that by seeing that, you can identify that this need to be done using your Poisson's distribution. See, again I'm saying, in your Poisson's binomial distribution, P and Q value will be greater, but N value will be very very low. Okay? And compared to your Poisson's distribution, P value will be very very less and your N value will be very very high. Okay? Okay, so this is the basic difference. Okay, now we shall take up another problem and solve it and identify, because in this problem they have not mentioned. In earlier problem, in a previous video what I have solved it, in that they have mentioned that clearly, that using Poisson's distribution solve this, but in this problem they have not given that. Okay, so how to solve it? Okay, we shall solve. Okay, 2% of the fuses manufactured by a firm are found to be defective. Okay, okay. So there is a factory, again there is a factory which produces fuses. Okay, in that 2% of fuses are found to be defective. In the 2% of, now the question arises, they have given only the probability. Okay, they have given only probability of some fuses are defective. We don't know how many fuses are defective. Okay, how many, the only the probability of each fuse to be defective is 0.02. The 2% is nothing but your 0.02. This is a basic thing. You know 2% is nothing but, if you do 2, you need to, if you want to convert this 2%, then just you divide it by 100. 2 by 100 is nothing but 0.02. So this is your probability for each fuse to be defective. Okay, and I don't know how many fuses are manufactured. First I want to know that, find the probability that a box containing 200 fuses. Yes, now they have given probability. See probability they have given 0.02. that means after point there is a 0. If there was a non-zero number, then we would have done binomial distribution, but in this case after point there is a 0, then we should go for your Poisson's distribution. Again, if you want to verify, then N value, as I said, N value is greater, much greater. 200 they have given, N value is 200, but okay, N value is also 200, but whereas in your binomial distribution it was supposed to be your 10 or 20 or 30, like that the N value varies, but here N value is 200 and your P value is 0.02. And similarly follow the same procedure to follow the Poisson's distribution. First I have to find the mean, that is nothing but M, which is equal to NP. Mean is equal to N is 200 in my case and P is nothing but 0.02. Okay, so my M value will be equal to 4. Clear? Okay. Okay, so now I have got, now substitute in my general formula of Poisson's distribution. P of x is equal to m power x e power minus m divided by x factorial. This is my general formula. I know what value? I know m value. Okay, that's all. I know only m value. Okay, then you substitute it. 4 power x into e power minus 4 divided by x factorial. Okay, so P of x, if you want to simplify it, if you want to make it very accurate, if you want to solve it very easily and very quickly, then you can go for it this method. Like 4 power x can't be simplified, then put it as it is. Then x factorial can't be simplified, then put it as it is. But e power minus 4 can be simplified. That means e power minus 4, which is nothing but 0.0183. So you can put it as 0.0183. In bracket you can shift this. So this will be your probability for only just, this is the probability for, this is general probability formula. Okay, this is a formula. Okay, now this x value I have to find. X value I have to put it in the substitute in this formula so that I can get some respective answers. Okay, that depends on my conditions. So in first condition there are no defective fuses, that means there are 200 fuses. There are 200 fuses in which the probability for a fuse to be defective is 0.02. and now they are asking how many fuses I mean in among 200, what is the probability for no defective fuses? That means nothing is defective, everything is perfect. All 200 fuses are perfect. That means my x value is, in first condition, x value will be 0. Substitute in this. P of 0 is equal to 0.0183, 4 power 0, 0 factorial. I have already told you 4 power 1, anything to the power 0 is 1, 0 factorial also 1, so my value is 0.183. Okay, is it the answer? Yes, this is the answer for first condition, 0. That means this is the probability for a fuse to be defective. For you, I mean to say this is the probability for no defective fuses. That means this is that means there are no defective fuses among 200. Okay, this is the probability for that. Okay, now I want to find the probability for 3 or more defective fuses. That means 3 or more fuses, more defective. That means my n value is 200. Okay, that means 3 or more. It might be among 200, it might be there might be 3 defective fuses, or there might be 4 defective fuses, or might be 5 defective fuses, or might be 6, or might be 7, 10 till 200. It might be till 200 defective fuses. What will be the probability for this thing? That means 3 or more. How to find? I cannot find for single 3, 4, 5, 6, 7, 8, 9, 10 up to 200. I cannot find. This is hugely impossible thing. I mean, it can be done, but it takes hours together. So it is a waste. It is a waste of time. Okay, so I have told this method in your binomial distribution also. So in this method also, you need to follow the same rule. Okay, so as I said, 3 or more is nothing but P of x greater than or equal to 3. 3 or more. 3 or more. That means 3 is also included. They have clearly mentioned. See, 3 or more. It might be 3. It might be 3. So that's why I have written equal to also. It might be greater than also. That means if I want to find, that means P of 3, P of 4, P of 5 till P of wait. Okay, P of 0 plus P of 1, P of 2 plus P of 3 till P of 200 is equal to 1. This is the formula, you know. I need to find P of 3, from P of 3 to P of 200. I cannot find this whole thing single by substituting each and every number again and again. Okay, just I need to go back. There are previous numbers. Okay, P of 0, P of 1, P of 2. You keep this P of 3 to P 200, that is which can be denoted as P of x greater than or equal to 3 as it is, and is equal to, you put it as equal to and you write it 1 as it is. Then you transfer whole these 3 terms this side. That means it will become minus of P of 0 plus P of 1 plus P of 2. Bracket close. That means this whole term I have taken it out and just I have put it here. Okay, now I need to 1 minus, I need to substitute this single values in my Poisson's distribution formula and get my answer. For this, first I need to substitute in my Poisson's distribution formula. I need to substitute here 0. That means this, in my case, this is the formula. I need to substitute here 0. Okay, then I'm going to get answer. Plus I need to substitute here x plus 1 and x plus 2, and adding those 3, then subtract it in 1, then I'll be getting my answer. So let's do it. First, P of 0 is nothing but 0.0183. You do one thing. You just 0.0183 will be common for all the 3 things. Why you can't take it out as a common term? You just do it. 0.0183 is being taken common outside. Okay, now this is the values which will be going to varying. Okay, for x in place, one time first time we'll substitute here 0, then 1, then 2. Okay, let's do it. 4 power 0, 0 factorial. Next 4 power 1, 1 factorial. 4 power 2, 2 factorial. Khatam. Now simply simplify it. Okay, if you are getting confused, you can solve it directly also in your calculator. But if you are getting confused, then you put it as 1 minus as it is, and then first you simplify this term, then you subtract it in minus in 1. So just 0.0183 into 4 power 0, anything to the power is 0 is 1, 0 factorial is 1. That means 1 plus 4, 4 power 1 is 4 only, and 1 factorial is 1 only. That means direct 4. 4 by 1 is 4, plus 4 square. 4 square is 16. Okay? 4 square is 16 divided by 2 factorial is 2. 2 into 1. 2. And now bracket close. You got 0.2379. Now you just subtract this in 1. Okay, 1 minus 0.2379. So your answer will be 0.7621. Am I right? Yes, 0.7621 is my answer. So this will be the probability for 3 or more defective fuses among the collection of 200 fuses manufactured by a firm. Okay, so this is the problem of Poisson's distribution. I hope you are clear. I tried as much as possible to go in depth with this, so that you should get my point. Okay, so I hope it's clear for you. If you have any queries or doubts, you can comment down below. Okay, for today that's all. In next video we shall be discussing about some more problems with this Poisson's distribution, or else we'll move to some next topic. Okay, thank you.